So welcome back guys. Now we will start learning the concepts of L3 routing. So you can presume that this section of the course is the most important section of this course. The concepts of L2 routing and L3 routing should be on your fingertips. So we will go through the concepts of L3 routing in three phases. In the first phase, we will discuss the topology setup that we will be using to understand L3 routing. In the second phase, we will understand that how network layer, that is L3 layer, works and what are its operations. And after building the necessary background behind network layer and its operations, we will go through the step-by-step example of L3 routing. So let us start with the discussion of the topology setup that we will going to use. So you can see that in this topology we have four routers. The name of the router is VM, VM1, VM2 and VM3, right? You can see that all these four routers are connected via point-to-point links. So this is point-to-point link, right? The common subnet which is shared between the router VM and the router VM1 is the subnet 1, which has the network ID 192.168.4.0/24. Similarly, subnet 2 is the common subnet which is shared by router VM1 and router VM2, and the network ID of this subnet is the following. Similarly, we have a subnet 3 which is a common subnet between router VM2 and router VM3. Now against each of these routers in this topology, you can see this little box. This little box is nothing but it is ARP table. So the number of entries in the ARP table of each router must be equal to the number of neighbors the router has. So it is for this reason that the router VM has only one entry in its ARP table. Router VM1 has two entries in the ARP table because router VM1 has two neighbors, that is router VM and router VM2. For the same reason, router VM2 has two entries in the ARP table and the router VM3 has only one entry in its ARP table. So just to recap, the ARP table contains nothing but it contains the mapping between the gateway IP address and the MAC address. You can see that each interface of each router in this topology is configured with the MAC address. So let us take an example for router VM. For example, the router VM has an interface Ethernet 2 which has a MAC address MA, right? And similarly, you can see that all other routers in this topology has MAC address configured on each of its physical interfaces. Now let us discuss what are the subnets we have and what subnets are local and remote with respect to each router in this topology. So you can see that for router VM, the remote subnet is subnet 2, right? And the another remote subnet is subnet 3. So with respect to the router VM, the local subnet is subnet 1, right? So why these subnets are local and remote? Just apply the definitions of remote and local subnets which we have already studied, and you would know that which subnet is local and which subnet is remote with respect to a given router. Similarly, with respect to the router VM1, subnet 2 and subnet 1 is a local subnet, whereas subnet 3 is a remote subnet, right? Same goes with router VM2, that is this router. Subnet 1 is a remote subnet for router VM2, whereas subnet 2 and subnet 3 both are local subnet for router VM2, right? And for router VM3, the subnet 2 and subnet 1 both are remote subnet, whereas subnet 3 is a local subnet for router VM3. Now next, let us discuss the routing table that we have configured in each of the routers routing table. So let us discuss the routing table entries for the router VM. So you can see that there are two entries in the routing table of router VM. Now the first thing is that why do we have two entries? We have two entries because in this topology there are two remote subnets with respect to the router VM. So remember, in a routing table we always install the entries for remote subnets. So you can see that 192.168.5.0/24 is a remote subnet which is subnet 3, and 192.168.1.0/24 is a remote subnet subnet 2, which is again a remote subnet with respect to the router VM. So now we already know the semantics of L3 routing, that is, what is the meaning of this routing table entries. Now for router VM1 there is only one remote subnet which is subnet 3, and therefore we have an entry for remote subnet 3 network ID, right? Same is true for router VM2 and same is true for router VM3. In this routing table entry you can ignore these fields. It is of no use here and is not worth discussion. So always remember that in the routing table of an L3 router, we always install the routing table entries which dictates how to reach remote subnets. Now you can see that for router VM1 we have an ARP table, for example. So router VM1 has two neighbors, that is router VM2 and router VM. So you can see that the router VM1 has neighbor IP address which is 192.168.4.2, which is an IP address of the opposite end of this link. And the MAC address of this physical interface is MA. So the router has IP address to MAC address mapping for next hop IP address, right? Similarly, for another neighbor, that is 192.168.1.2, the router VM1 has an IP address to MAC address mapping. Similarly, ARP tables for all other routers in this topology are populated. So when a packet is routed in the network, essentially 4 fields in the packet we need to closely understand. What are those fields? The source MAC address and destination MAC address present in the Ethernet header of the packet, and the source IP address and destination IP address present in the IP header of the packet. So these 4 fields determines the path of a packet in the network. And you can see that in this topology we have not deployed any L2 switch, right? So MAC table is out of question. Also we assume that ARP tables of all the routers in the topology are already populated, right? So we have assumed that ARP tables are populated so that we can avoid the redundant discussion of ARP resolution in this example, and we can focus only on L3 routing concepts. So this is the topology I have explained. We will run L3 routing example on this topology in order to explain the L3 routing concepts.